All right, let's get back into it. So, I had a few questions come in about what is Pixies. I've had really good success with the video that takes us all from CAD parametric data into Pixies, into Substance Painter, into Unity. But that's the one piece of the puzzle that many people haven't heard of before. So, let's dive into Pixies and understand what it is. I've got it pulled up here, and this is Pixie Studio. So, to take a quick step back, Pixies is a suite of tools. It's a company that Unity acquired a few years back. And the idea of Pixies is that it's kind of the one stop shop for data tessellation, decimation, and optimization. And the idea is that you can input parametric, polygonal, and point cloud data, pull it all through a pipeline, and spit out something that's palatable and optimized for web viewing, for desktop viewing, whatever it might be, generally done in Unity. So there are four different pieces to it. The plugin is a piece of Pixies that is a plugin inside of Unity that allows you to open up Unity, open the plugin, and import CAD data such as step, STL, IGES, etc. directly inside of Unity, so you never actually need to leave the Unity editor. Pixies Review is a collaboration and review tool to visualize CAD data and then hop in and see it in VR and do all that kind of neat stuff. And then Pixie Studio is what we're going to look at today, which is more or less all of the functionality of Pixie's plugin, except it's in its own 3D software, its own 3D viewer, and there's more breadth of items that you can customize, and you can start digging into the Python scripting part of it, etc. Lastly, we have Scenario Processor, which is the automation tool for something like Pixie Studio. So what you do is use Pixie Studio generally to pull an asset all the way through the pipeline, figure out how you want to optimize it, and then you can save out that recipe of combination of things that you've done and run it in a loop in Scenario Processor, just setting up something like a folder watcher that can just sit there as a service and watch a folder. You drop a cat file in there, and all of a sudden it pulls it through and spits out an FBX for you without you needing to lift a finger. So that's the idea. Those are the four products. Studio is kind of my bread and butter because I'm traditionally a 3D modeler, and that's always worked really well for me, having that 3D viewer window. So I guess before we dive in, the last thing I'll show is just supported file formats. So I had this pulled up. For those of you that are wondering what exactly is supported, it's all the stuff that I can really think of. So you've got AutoCAD, Inventor, Revit, CATIA, Creo, GLTF, IGES, JT, OBJ. I could keep going. But that's the idea, is that all of this can be imported in, and then it also exports out certain types of files as well. So let's dive in and let's use an asset that we're all familiar with, which is the radial engine that I've used before. This was just pulled down from a kind of an open repository of CAD data online. So thank you again to the original artist for this. Let me pull in the radial engine. I'm going to do this with a raw import. So I'm actually going to change from guided to raw. And we will pull in the STP. All right, so the idea of this is that it works with both parametric and non-parametric, meaning polygonal data. So what we're looking at right here is all BREP or parametric data. If I turn off BREP, we're not going to see anything because that's all that exists right here. You can also see that there are no triangles, yet we have a lot of part occurrences. That means that there is no tessellation, no geometry yet. It's all parametric, it's all BREP. So first thing I want to do is come in here to CAD and do repair CAD, execute. There are a ton of settings within all of these settings that I can get into as we find relevance or as I get further questions, but everything has more advanced options. So here I can actually generate a UV map along with the tessellation of the data. I'm just going to keep it all default, but let me know if you want me to come back and cover any of this at length. And we'll do a low fidelity preset. and execute that. So if I look at the wireframe right now, we can see our wireframe. It's nice and low fidelity. If I needed to come back out here and do a, where would we go? Retessellate perhaps. Let's say I want to turn on max length. So this is the maximum length of the separation of edge loops. So you can see here, it was able to go back in and add back in the fidelity. That's because when you do something like a retessellation, it goes back to the parametric data to do that retessellation. It's not trying to retessellate the geometry, if that makes sense. So it's a pretty intelligent system here. You can tessellate different objects as we just did at different levels of fidelity, which is typically extremely helpful for things like nuts and bolts. One of the things that I'll use in here will be a optimization of the mesh. So we have 176,000 triangles here. If I want to do a smart hidden removal, that will essentially fly around the outside of the object and cull anything that it doesn't see. So if there's anything existing within an object like this, it can start to delete out things that cannot be seen at all from the external camera. We can also come back into here and do a mesh optimization, remove holes, which will just remove any holes in the mesh that you didn't unintentionally want in there. And then let's decimate to quality and set this to low. Again, with inequality, you can set all of these to different subsettings that get you to all different levels of decimation. I'm just going to execute it with the standard. So here we have 102,000. So let's say my budget is 100,000 for this piece. I can also come in here and generate LODs, but just for the sake of the time that we want to spend on this today, we'll bypass that for now. But let's say I go back in here and just brute force it to 100,000. I'll execute that, and it will now do the decimation for me. And I can turn off my wireframe just to make sure that things are still looking good enough for my fidelity that I want to show. And I'm pretty happy with all of this. So we got it down just shy of 50% less than it started at 176 with the original tessellation at low quality. I'm good with that for right now. If we want to keep playing with this, we absolutely can. Again, you can get in all of those LOD systems and whatnot. You can see that there's some pink here for the normal faces. So we have BF color is turned on, meaning backside or back face color. If you want to cull the back faces, then you can do that. Or if you want to just have them lit as if they're two-sided, you can do that as well. We can also turn on the UVs, which we notice something immediately here, which is that there are no UVs on this, which is a problem. So let me come over here, and instead of trying to generate from up here in the menu, I'm going to use one of the tools that I use often, which is coming over here into these tabs. So within the tools, we have measurement, selection tools, cutting plane as an example. You can actually use to look at, and I'll turn back off the checker for now. You can come through here and look at different components. That's very helpful for visualization. Exploded view, so if we really wanted to, we could explode components out and look at them that way. But what I generally use is this UV projection tool. So let's say I move this along, pretty happy with it overall. I don't really need to scale much, so I'm just going to apply that to the selection. And now when I turn on checker, you can see that we have a UV map created. So what I want to do now that we've done a UV projection tool is I want to go into the UVs and I want to normalize the UVs so that they'll all fit in a 0 to 1 UV space. And then I'm going to execute. So that all runs. And then I want to come over in here and do a repack and execute that. So it's repacking to try to make the most efficient layout in the 0 to 1 UV space. And as soon as that finishes, we can then open up our UV viewer. and see that all of those are laid out perfectly fine. So it's kind of what we generally would call a garbage map in the modeling world, of just everything is auto laid out. But it works pretty well, especially for going into something like Substance Painter where you can paint directly across seams. So anyways, there are some of those tools. I'll turn off the UV map. And if we wanted to get into visualization and things like that, we can start to show this thing in an actual 360 environment, which is always pretty neat. Outside of that, what I'll generally do at this point is if I'm happy with it and I don't need LODs, we can pretty much call it good here, and we can come over to File, Export Scene or Export Selection. You could also separately come over here to Export, and all I have to do is just change the name. So all that you do is change the suffix. So if I wanted this to be an OBJ, I'm just going to type in Radial Engine OBJ, and it will export it as that file type that I can now use. A few other things that I want to hit on while we're here. So down here we have a scripting component in the UI. We did not use this, but the idea around the scripting component is that everything that I just did on the front end is programmable in Python. So if I come in here and I go into, let's see, where sample files, oh, sample scripts, here we go. So if we come down here to sample scripts, we can then see a bunch of different scripts that are laid out here. So if I want to show what 101 generic process looks like, I can pull that into here, and you can see a lot of what it's doing. So it's doing a repair CAD, it's doing a tessellate, a repair mesh, a remove holes, a hidden removal, a delete patches, and a decimation. So all of that's being done within one script to different levels of settings that are predefined in here. So if I were to hit run on this, after doing a raw import, it's going to execute those for me. Another way to get through all of this is go to guided import, pull in that STP, and it'll have a lot of these settings already set up for me. If I want to bring in things like PMI data, variance, etc., it essentially runs through some of these generic processes for me. And now I can pull this, and it looks pretty dang similar. So that's the idea of how that would work. If you're ever moving an object around, just as one small shout out, if you have move pivot only, it's going to move your pivot, but it's going to appear that your 3D data cannot or will not move. Just make sure you go under transform and move that around. So the idea of all of this is the automation of this process. What I could generally have done in Maya is something comparable to many of these settings, but I could not have done it in a way that's immediately replicable and put into a server and ran in an automated fashion using something like Scenario Processor. This tool is very much specialized at doing exactly what we just did, among a few other things. But we'll leave it here for today. I feel like that's a pretty good overview of PiXYZ. So yeah, one last thing that I'll cover is I'll delete this one out. We'll keep this one here. And if I want to start coming through here, I can not only start to merge my tree by the level. So I could come over here and say these are all at level 3. I don't really need that level 4. So let's say max level 3, execute. It's now going to force all of these to compress into that level 3 in the tree, which is really all that I need for my purposes. So that's a way to clean up the hierarchy. And then let's say I've found one piece that I really like. I can go into search, and I can search for anything with the name of what I just highlighted. And now in the inspector, you can assign materials. So if no materials import with the object, you can create some basic ones and begin to apply those around. So really nothing too fancy here, but the ability to create mats for masking out different materials inside of a material ID mask or something else is where we're headed with this. So if you look at our longer tutorial, we go through the process of actually creating a material ID mask and then applying that within Substance. But that's a quick look at how you would have applied that here. Also, anything that comes through as far as metadata, you'll get to see in that inspector over here. So hopefully that was helpful, informational. and we'll get everyone on the journey to working with CAD data faster and more efficiently. Let me know if there are any questions. Like, comment, and subscribe, and thank you for watching. Have a great day.